Hi there and welcome back. Right, today is the 2nd of December and it's getting close to Christmas, and this ugly old beast is still not rolling on the ground. I've got a couple of things more to do. If you follow the show up to now, you know that I've reassembled the cylinder head, put that back on the engine, and I've got the engine started. And last video I made efforts at getting the control systems working, with some success, some not. The clutch cable needs to be repaired, but I got that off and I think I can repair that fairly easily. I've had a think about that, and I've got some thoughts to share on that, but I'll do that in a little while. Second thing was the accelerator cable and the pedal, that was all freed off and working perfectly, and then the little cable end decided to break off the end of the cable because the cable was so thin. So I've got to take that off and get a new bit of cable and a new end. So again, some thoughts to share on that, but I'm not too worried about that today. I can easily get that off, and I won't show too much of that because I need to get some parts. So not too much of that, but I will share a few thoughts on that one, where we're going to go with that. And the main job for today is working out the electricity on this machine. Now, this is a 1953 truck, so the electrics, they are 1953. They are pretty ropey, but I have seen a lot worse on a lot of old equipment like this, where all the insulation is all cracked and broken and falling to pieces, and all the copper wire has all gone manky and black and green. Actually, this isn't actually too bad. I suspect, because unlike a tractor, which is what I work on most of the time, old tractors with electrics, the electrics are not exposed to the elements. They are under a bonnet, they're under a cab, and it's all nicely contained, whereas on a tractor, yes, they might be under a bonnet, but most of it is exposed to the elements and the weather, whereas on this, it's not. So we've got a fairly good looking electrical loom. But I suspect what I'll have to do is I'll have to put a new loom on it, which won't be cheap eventually when it's restored. If I want to, and I want it properly done, I don't think I shall bodge my own loom together. It's as of the period, it's not PVC wrapped or anything, it's cloth wrapped, and you know, it needs to be the correct one. So maybe I'll get away with it, I don't know, until I get it to pieces. But what I need to do to start with is I need to get a permanent feed from the battery to the switches so that I can operate the starter and the heater switch in the cabin, so that I can start the thing from the cab. Not bothered about the ammeter, not bothered about the key switch. I don't have a key anyway, so I can't get the key switch working whatever happens. But I can get a feed, I think, from the battery through the system up to the dashboard and onto the backs of the switches. So I'll take you around where we're up to so far with this, and what I'm going to do next. So yeah, let's have a look, see what we can find. Right, okay, so we can see there that we've got the seat base up and tilted forward. It hinges on the front edge, and the seat back sits on the steering wheel, holds it up. So underneath, that's where the battery is stored. Pretty hefty battery box. Don't quite know, we've got so much space there. We've got enough for two batteries side by side, but don't know what the reason is, unless originally some of these may have been 24 volts, so you had two 12-volt batteries side by side, but anyone's guess. This piece of steel here, that's about 2.5 inches thick, and is acts, basically the whole thing here acts as like a counterweight over the back wheels. I would hate to think what the heck that weighs, but that is going to be a fairly hefty bit of iron there. It's pretty huge. It's about 2 foot long by about 1.5 foot wide and about 1.5 foot high, and it's about 2.5 inches thick all the way around. And I don't know how far down it goes, but it goes right above the back axle. So that clearly is to give the thing some weight on the back wheels to give it some grip. Anyway, I digress because we're talking about electrics today, and more about the chassis when we come to strip the thing down. but you get a bit of an idea what this thing's built of. Now it's positive earth, as a lot of machines of this period would be, but it is 12 volts, so I'm going to put a 12 volt battery on it. Certainly 12 volt starter from what I can remember, and that's what I've used anyway. It doesn't really make a huge amount of difference in this case particularly. I mean, we're only going to be using switches and stuff, and 12 volt just gives it a little bit more of an extra. The only downside might be that if it is 6 volt, and I haven't looked into it that deep, that the generator might go bang, but not worried at the moment. I might just disconnect that generator before I start it up. So here we have the battery, as I say, positive earth, and this lead here comes out all the way out from the battery box, down this step here, loops down the bottom, and it comes up that bulkhead to a switch, which is like an isolator switch, which by the look of it has been bridged out, because the two cables are now joined together at the switch here. So clearly that probably doesn't work, or they just decided it was a pain to use, so they bypassed it. Again, not worried about that, because we can always fix that. That's not a problem. And then it goes back the same way and back into the battery box until it comes in back on here, and it connects to the big counterweight underneath the seat. That is your earth connection. It's a chassis earth, like every other automotive vehicle there is, so that the battery basically completes the circuit using the chassis as the earth or the ground. And on the other side we've got the negative cable on the battery there going off to the other side of the cab, and that goes out into the engine bay. This is where the main feed comes from the battery onto the starter. This one here is the starter solenoid, so that comes from the starter switch to throw the starter to start the engine, and the one above it, that is your heater element, which goes onto the bottom of the heater element just there. You can see my red wire that I used the other week to get the heater element started with the slave battery. That screws onto there, and what we've got to do, we've got to first of all trace battery voltage from this point here to the dashboard, and then back from the dashboard through the switches to starter and heater element. And that's all I'm interested in at the minute. Not interested in any lights, wipers, horn, ammeter, key switch or anything, because we don't need a key switch to start this thing. We just need the button to throw this solenoid in to get the starter started, so that the engine will start. That's all I'm bothered about. As I said already, probably disconnect the two wires off the back of the generator so that I don't put anything undue voltage or whatever through there and blow the generator up. Probably take those off, just loosen off. Two different sizes here, you can't get them wrong. They can just hang there for now. The generator will need probably rebuilding anyway, so if I run it and it messes it up, so I'm not too worried. I just want the thing to run really on the floor, and we come to all of that other stuff at a later date. So what I'm going to do next is trace 12 volts from here, or possibly continuity from here, up to the fuse box, and then go from there. So the first thing that I need to do is I want to see if I've got any kind of current flow from the battery into this machine at all. And the way to do that very quickly and easily is connect the battery. So when I connect the battery terminal to the battery lead, if I get any kind of spark, I know that I've got some current draw already, and something is drawing electricity from the battery. It doesn't need to be a big spark. Any kind of spark will give me an idea. So if I take the light away, hopefully I'll be able to see that if there's any kind of electricity flowing, just because there's a spark. If there's no spark, I'll be happy. So I'll take the light away and connect up the battery. Nothing at all. No spark. No nothing. So I'm happy that we've got no electricity flow. So I'll tighten that up, and then we'll trace it through from here, or rather from here, to the starter motor. Okay, so first off, what we need to do is we need to see if we've got our 12 volts coming from the battery to the starter. So we go onto the starter terminal, main battery lead in, and there we've got 12.65 volts coming from the battery to the main starter terminal, and then that then goes up that little tiny wire there into the main loom and off and away. We've got nothing on the generator wires at all, nothing there, 0.1 of a volt, so we've got something happening. That's probably through the regulator. We've got nothing on the heater element, and we've got nothing on the starter solenoid, which is what you'd expect, because these both are controlled by switches and they would not work unless you push the switch. So we'll have to find out whether they've got permanent feed to them at all, so that when we push the switches, whether we get 12 volts at these. But we've got 12 volts up to the starter, which is the right thing we need. So next thing is we need to follow that up to the fuse box. Okay, so coming up to the fuse box, we've got two fuses side by side. That one there, we've got 0.5 volt on there, on both sides of that fuse. Okay. And then on this fuse here, on this side, we've got our 12.65 volts. And at the bottom of that fuse, we have 12.65 volts, if you can see on the meter at the bottom there. Now, I believe that our 12.65 volts is coming in at the top of the fuse box. And the reason I say that is because if I take that fuse out, and if I measure it, I've still got 12.65 volts. If I measure the other side of the fuse, I've got zero, got nothing. So the feed, the circuit is coming from the top of the fuse box down through the fuse and away through that wire there into the main loom, and hopefully away to the dashboard. Now this is where it gets a little bit murky, because I've gone onto the dashboard and I've got absolutely no way of finding at the moment any kind of continuity from this fuse, bottom of this fuse, into the key switch. Okay, so I know I've got power to the top of the fuse and I know I've got power through it, so the fuse is good, but I've got no voltage and I can't find any continuity on the dashboard. So let me take you around there and show you what I mean. Now what I'm going to check for now is, instead of checking for voltage, I'm actually checking for resistance and continuity of the wiring from that fuse, the bottom of the fuse. So I've got the crocodile clip connected to the fuse, which is connected to the bottom of the fuse holder, which then is connected to the wire that goes into the loom, and I'm expecting that wire to come out in the dashboard and feed the key switch, because the key switch is basically your governor. That's the bit that you need to be able to use to control the electricity, to switch it on and off in an emergency and such like. Now the engine emergency stop, or the engine stop, is a cable pull, but if you've got a problem with lights or you know, you've got a fire or something happening on electrics, you need to switch off your electricity as soon as possible. You use the key switch for that, and then of course you've got your isolator switch, which I showed you earlier, for the main battery positive. So you've got a number of different things. So the key switch is there to basically switch the auxiliaries on, but also switch on the switches that operate the heater and the starter. But I need to bypass those, but ultimately I want to find out how I'm going to bypass it. Now, I don't know if you can see, but it's pretty difficult to get because of the way the dashboard is laid out. But effectively, I'm trying to get a continuity check between these wires and the fuse box, and at the moment I'm getting absolutely nothing. So I don't know if there's a break in the wire somewhere. If I basically, I'm listening for a bleep, because I've got my meter set to bleeping, or noise, whatever you want to call it, buzzer, continuity checker, and I'm getting nothing off of any of these terminals which are on this key switch here. So there is no connection from that fuse, the main fuse in, with battery positive. There's no connection to this key switch whatsoever. So that is not a good start. So not entirely sure where we're going to go next. I do notice that the ammeter, which is this one here, the ammeter is actually disconnected. This side is broken off because there's a green wire which is sort of hanging free. There's the end of it. There's the end of that. So I think that obviously been disconnected. That would be in series with the main battery positive to the key switch, or somewhere similar, so that it would monitor the amps that the generator is producing and going to the battery. This is a bullet connector, and I've got a spare bullet connector, which is basically that one there. So that is just hanging free. I don't know why that's been disconnected, but that, I suspect that goes with that, but I don't know yet. We'll have to wait and see. Now what I think is supposed to happen is that from the key switch you get a feed from the fuse, you get a feed into the dashboard, into the ammeter, through the ammeter, out the ammeter, onto the back of the key switch, and that gives you your feed for your main switches and key switch and your starter and your heater. That's what I think should happen. But as I say, this one's disconnected, and I don't know if that should be from the fuse box. So if I try and bell that out with my meter, put my meter in there, but again, I'm getting nothing continuity wise through any of these wires. If I go to this one here, again, I'm getting nothing. Any of these two switches are your starter and your heater switch, nothing on those. It's all very, very quiet, which is not very good news at the moment, but we've just got to persevere until we find it. I say that these wires have no colour. What it actually is the colour is underneath this. It's like a shellac sort of, I don't know if shellac's the right word, but it's like a woven insulation over the PVC, which is underneath, and some of the wires are bare, and you can actually see that they have got a colour. Some of that one's black. If I peel that back, I don't know if you can see that, but that wire is a black wire there underneath the weaving. So there are some colours. Again, this one's green and brown. That one's a red one. That one's a yellow. That's clearly original. This one's green. That could be original. It might not. I don't really know. It's very difficult because I haven't got a wiring diagram either. So there's another black wire there. So I don't know what that's for. I don't know if that connected into there or what. I'm not really sure at all. So we've got to go looking elsewhere, I think. So let's see what we can find. Okay, so what I have found is I've found two wires which are broken. Now, if I put my meter on there, you can hear I've got continuity. Okay, and that is directly to the bottom of the fuse at the top in the fuse box. So there I have got continuity. So that wire comes directly from the fuse out of the loom. It comes out of the loom down here behind the panel here, and it sticks out. Why it's there I don't know, but it was broken, and I've basically peeled back the insulation, which is actually very clean wire underneath, and if I put my meter on it, there I have continuity through there. So that wire is the 12-volt feed from the key switch. The one next to it, if I bell it out with my meter, nothing happens. So what I'm going to do next is I'm going to put the crocodile clip on that end and go back to the dashboard and see if that comes out of that empty bullet connector that I've got. Okay, still on continuity. I've got my crocodile clip on that other bare wire, and if I go to this wire down here with the empty, there we go, we have got continuity. There we are. So that wire that is in there, I mean at the minute, that must plug in to that ammeter bullet. That then from the ammeter goes to the key switch. The key switch then's got its live feed. The live feed is then distributed by the key switch to where it's needed for the switches and the auxiliaries. That is all I need. I just need that live feed there to then go on to these two switches here, the heater and the starter, to give me main heater and starter operation. So the other thing I want to do before I do anything else is I want to see if these switches work, the heater and the starter. So I've got the heater cable connected up with the crocodile clip. That is the end of it that goes onto the heater terminal on the coil, on the manifold. And I'm going to just try the switch with continuity. And the heater is the bottom one. And I've got continuity in the wire from the heater to the switch, so that's good. And I've got nothing through the other side of the switch. You can just see it there. Maybe I'll just move my camera. You can just see it there. But if I now press the heater switch, hopefully I will have some continuity. Yes. So that switch is good. we're happy with that. That's really good news. And now I want to do the same with the starter switch. So the top cable should be the one that goes to the starter solenoid. I've got the crocodile clip on the starter solenoid terminal. And if I put I've got continuity from the switch to the starter motor, which is also good news. Now the starter motor switch is the likely one that's not going to work because I suspect it's probably burnt out inside. So if I put my probe on the other side of the switch and operate the switch, I had a bleep, but now it's gone away. There you go. That switch needs a bit of a clean up, I think. Now these switches are really good switches because they are proper CAV switches, and CAV was a company that back in the day, I think they may still be around, I'm not entirely sure, but they make quality equipment and electrical equipment, starter motors, switches, etc. Also diesel filtration and fuel pumps and all sorts of other things. But CAV was a good name, and these switches are CAV, and the beauty of them is you can strip them apart and clean them because they're all screwed together and not riveted or bonded or anything like that, anything you get these days. So we can get the switch off and we can get the thing out of the dashboard, get it apart, clean it up, and that will give us a good switch. So there, as you can see, the back of the switch unscrews, and if I can get it in focus, I'm on my action camera, which is not very good at focusing, of course. You can see that that's the back of the switch on the outside. There's the two terminals where the cables screw onto, and then on the inside I've got two contacts, one of which is pretty black. They basically are two sides of the wires, two sides of the switch, and then if I push up the plunger from the inside, you can see that we've got a brass plunger, which you can see is also got some black marks on the end of the plunger, and they basically, what all that does, that basically just connects the two contacts on the back plate of the switch and connects the switch together. And the starter motor switch is going to be the one that's going to take the hammer, probably, because it's going to take quite a lot of current to throw that starter. And it probably gets used a lot more than the heater switch would get used as well, because once the engine's warm, you wouldn't use the heater switch again in a day, whereas you might use the starter motor maybe 10, 15, 20 times a day. The heater switch you only use once, so or maybe twice. So I'm going to get some wire wool or some emery cloth on the end of that switch. I'm not need to take it out completely because I can get to it quite easily, and I'll probably, because it's so easy, I'll probably do the same thing on the other one as well, just to clean the contacts up and make sure they're good contacts. And then hopefully we might get some electricity down to that starter motor all working. I've got to connect that wire together that I found broken. I don't know why it's sticking out of the loom. There's just broken. There's no bullet connectors, nothing. There's no ends to it on either of them, so I don't quite know why that's like that, but I'm going to connect it together so I've got a feed up to here, and then that should give us 12 volts through the switches and off to where we need it. So get some emery cloth or some wire wool and give those contacts a clean. So I've got the heater switch part now, and this one is just as black and horrible. And if I go down onto the actual plunger itself and just raise that up, you can see that one's pretty black and awful as well, so I'm going to give them a clean up. You can see I've done the starter switch, just given that a bit of a clean up. That looks much tidier. So get that done and then put these back together and we'll try them with some feed. That's looking better already. That's all it is, just a little bit of carbonation on the contacts. They're not even pitted hardly, it's just dirt. So that's all good news. That's good from that point of view. And if I just do the one on the end of the I'm just using a fine wire brush. That's what I had to hand. It's good enough for what we need, just to get that end of that plunger nice and clean, and then we get a decent contact and we won't have any issues. There we go. Right, there's the caps back on. Let's see if they work. There we go. That's all we need. That's the starter. that's the heater. Right, now, so I've connected the 2 broken wires up underneath the bonnet there, which means I've now got 12 volts at this point here. The red wire's gone back on the back of the switch. This originally came from the key switch, which would have been the main feed in from that fuse that I showed you earlier. But I've taken it off the key switch, and I'm going to plug it straight into this black wire here. Eventually this black wire will bullet to this ammeter, and then the ammeter to the starter. But I'm going to connect the two together here so that I can then hopefully press the starter button and the engine will turn over. So let's have a go at that. Fantastic. So that means we can now push the starter button in the cab and the engine will turn over. And I think with a bit of heat she'd probably go, but I'm not going to do that today. We've done that already. We need to concentrate on other things. So the next thing will be to put a bullet on this connector here so that that is permanently connected, or at least for the time being. We need to put the two that are under the bonnet, we need to connect those properly together, so that's done. And then we need to put a feed from here to the other switch so that we can get the heater working. And then that will get us back up and running, or up and running from the cab electrically for now. And then we can hopefully get it started from here. So there you go. We've got the electrics working in the cab that we need. We've got the starter switch working. We'll get the heater switch working just by getting some extra wires on that. I'll do all that off camera. You can see what we're up against. Old wiring, difficult to decipher which wires go where. It takes an awful lot of time trying to figure out what goes where. I've got no diagram for this thing, so basically it's a case of using what I know, using basic continuity checks, voltage checks to see where everything goes. I used to have a little 12 volt probe light, which I don't know where I've done with that, which probably would have been a bit more useful than the voltmeter, and probably a bit quicker as well, but I've been using the voltmeter and that's fine. So I'll get all that done off camera. Next time you come back to us, I'm hoping that we're going to have the front wheels on. I've got some tyres to put back on the front wheels. We need to put them back on the front so I can put it back on the floor. We've got to get the clutch cable repaired, the accelerator cable sorted out, a few bits and pieces on the engine with the water jacket, get the fan belt properly and the water pump, properly belted up, because at the moment that's just all free. Then we're getting close to where we need to be able to get it running and keep it running and control it as well. And then hopefully, if the clutch works, maybe we shall drive it. That'll be either next video or the video after that. Let's see how we get on. A few more things left to do. It's getting close to Christmas. I said I wanted to drive it before Christmas. Let's hope I'll get there. If you like what you see, please put a subscription down on the channel. If you're not already subscribed, it'd be great to have you along. Really, really want people to get involved with what we do. Happy to share anything that we've got. Happy to answer any questions. I've been doing this all my life. I might miss stuff as I'm talking, and I try and sort of educate people as I'm going along. But if you've got any questions about any of it, please just ask a question in the comment section below. That'd be great to hear from you, and I'll try and reply to everything that I get. I've had a couple of questions about a couple of things that I've done already, which I'll address probably in the next video if I remember. Put a like on the video if you liked it, and also share it to your friends if you've got people that are interested in this sort of stuff. And it'd be great to have you along. Really good. So coming up to Christmas, 2nd of December today. Maybe get something else done before the end of this week, perhaps next week, maybe the week after. She'll be a runner. Hopefully we'll see you then. Take care and bye for now.